In the previous video, we talked about this vector system. However, there was something important about it that I forgot to mention, so I'm going to do that now. So let's look at this system really quickly. I am going to now talk about the direction of vector A, B, and vector C. Their direction is very important. This is why we did this example. So when we look at the direction of vector A, we see that it's parallel to direction Y. And in this case, it's also coinciding, meaning that its location is literally along the y-axis. Let's look at vector B. Vector B's direction is parallel to the x-axis. So we're seeing a pattern here. And then the direction of vector C is parallel to the z-axis. So this is the Cartesian representation. We are adding these head to tail and it is giving us the resultant. However, the direction of vector A, B, and C are hand in hand with the Cartesian representation of vectors. Now, the Cartesian representation is right here. We talked about it in the previous video. So let's show vector R, this is our resultant vector, important. Starting point is point A to point B. So now let's see how we can show vector R in Cartesian representation. So let's start with the x direction, which is our I hat right here. So for our x direction, we see vector B. So we get the magnitude of vector B. If I said the vector, then this would be vector B, but we want the magnitude of vector B because our direction is already x. So then we do the I hat right here. This is the I direction. And let's see, now we got the I done. Now let's move on to J. This is the y-axis. And for the y-axis, we have vector A. So let's get the magnitude of vector A in the y direction, so our j hat. So we have our I and j direction, so our x and y directions. And since this vector is a three-dimensional vector, we want the z direction as well, which is given to us by this vector, the vector c, because c is parallel to the z-axis. So let's do that now. What is our magnitude? It's c without the squiggly line under it. And then we have the direction vector, which is k. This will represent vector r in Cartesian coordinates. This is equal to vector r.